In this video, we will create a set of rectangular beams. The beams node is currently empty. We need to get the arcs. Let's copy the code from the panels node. We need the query statement that gets the arcs. We paste the code here. We want our beams to go in both directions. For the beams that go in the longitudinal direction, we need some polylines. We can generate the longitudinal polylines by lofting the arcs. If we set the method to stringers, then the loft function will generate only polylines. Here we can see the stringer polylines. We are going to create the beams with a local function. We can first set everything up. We define a local function called createBeams. The function will have a parameter for the list of polylines that will be used to generate the beams. The polylines will be the centerlines of the beams. The function will return a value. It will return a list of polygons that define the beam shapes. We will complete this part later when we implement the body of the function. We can now call our beam function from our main code. We will call the function 2 times. First we will create the arc beams. And then we will create the stringer beams. We can straight away add the lines of code for the attributes. First we create an attribute for the arc beams. And then for the stringer beams. Note that the attribute name is the same for both. However, the value is different. Finally, we can also clean up. We only want to keep the polygons that belong to the beams. Everything else can be deleted. Now let's start implementing the body of the function. The first thing we need to do is to create a small cross-section for the beam. We will then use this cross-section with the sweep function to generate the beam. Our cross-section will be rectangular. So we generate a rectangular pattern of positions. The cross-section will be placed at the origin, on the XY plane. We will create a polyline from the rectangular positions. The polyline will be passed to the sweep function as the cross-section. We will loop through each of the beam centerlines, and create a beam. The modifications will be made to a clone of each polyline to prevent conflicts. The sweep function will be inserted in the body of the loop. The first parameter is the entity to sweep along. And the second parameter is the cross-section entity. Inside the loop, each time we create a beam, we will add the polygons to the end of the list. Note that we have chosen to add a list to the end of a list. This will result in nested lists. If we had chosen the extend option from the drop-down, we would get a flat list. When we execute, we can see that a set of beams has been generated. Ensure that the cross-section polyline is closed. We can see that the beams have a rectangular cross-section. The size of the cross-section is specified by the rectangle. Currently the size is 0.2 meters high by 0.4 meters wide. Let's try some other values and see what happens. We would like our arc beams and our stringer beams to be able to have different cross-sections. So let's add a parameter to our function. The parameter will allow us to set the size of the cross-section when the function is called. When we call the function, we can now specify different sizes for the arc beams and stringer beams. We can now see that the beams have two different sizes. The next step is to offset the beams. At the moment, then beams intersect with one another. And the beams intersect with the panels. When we select our skeleton, we can see the rays that we generated earlier. These rays represent the normals that we will use for offsetting out beams. Here we can see the direction of one ray. We want to offset our beams in this direction. It is typically easier to make changes earlier in the process. In this case, we should not try and move the beams themselves. They are already quite complex, consisting of many polygons. Instead, we should move the center lines that were used to generate the beams. The center lines are relatively simple. They will be much easier to move. To do this, we will go into the body of the for each loop. We will offset the center line before we do the sweep. To offset the polyline, we need to offset the positions. So first we create a variable and get the positions along the center line. The next thing we need is the normals on these positions. These are the normals that we will use for creating the offset. The normals were added in the skeleton node. We gave the attribute the name norm. So now we get the nor attribute from the positions. Next, we move the positions using the normals. The move function is overloaded. So we can pass in a list of positions and a list of normal vectors. The function will pair up each position with each vector. Now, when we execute, we can see that the beams have been offset. We can see that the arrowhead is now embedded in the beam. So the beams have been offset outwards. If we want to change the offset distance, then we need to change the length of the vector. We will set the length of the vector to 1. The beams will now be offset in the outward direction. Let's see how this relates to the roof panels. There are still a few things we would like to fix. We want to offset the arc beams and stringer beams by different amounts. This way, they will not intersect. To do this, we will add another parameter to our beam function. The parameter will define the offset distance. When we call the function, we will specify the offset. Now we can see that the beams no longer intersect. When we go back to the colors node, we can see the panels and the offset beams. In the next video, we will add the colors.